For this one, there is one solution that is given in the written form. I'll be giving you an alternate way of solving this question. Now, according to the level of difficulty, this question may come in a higher level of difficulty. But looking at the way I'll be solving it, you might consider this as a below moderate level of difficulty. Okay. Now let's first of all understand this particular series. Now it is 101, 82, 97, 80, 93, 78. Now it is not difficult to identify what pattern is being followed. So I'm sure that more than 90% of the students must have identified the pattern of these alternate terms. Okay. So alternate terms are in arithmetic progression and they have a negative common difference. So I'll separate these two series first of all. So 101, 97, I'll not directly give you the solution. I'll first of all make you understand why I'm solving it in the way I'll be solving it. Okay. Second series is 82, 80, 78, and so on. Now, since this is a theta question, it is very easy to commit a mistake to write a wrong answer. Okay. Now, some of you might do the calculation as because we want to maximize the sum of this series. So you may consider these two series separately. Okay. Find out the last positive term. Find out the last positive term of first series and then find out the last positive term of second series and then calculate the sum and find the answer. Now, that is not a proper way of solving this question. That is not a correct way of solving this question because the last positive term of this series and the last positive term of this series may not occur together. Okay. So if I look at the last positive term of the first series, it will be equal to 1 and the last positive series term of second series will be 2. Okay. Now, in the first case, 1 will be the 26th term, and in the second case, 2 will be 41st term. Okay, so I can say that the first series will turn negative before the second series, right? So, at what point the sum will be maximum, it will be difficult to identify. Okay, so I will use a separate method. So one way is you will keep on calculating the sum up till let's say 26 series and then look at the further terms. So 26 term tak calculate karo, uske baad like you look at the combination of two terms when the sum is getting negative and then stop there by using hidden trial, a little bit of hidden trial, or you have to get into the depth of this question. But the method that I'm going to tell you is very simple. Okay, now let's look at that method. Now what I'll do is I'll combine every two terms of this particular series. So I'll combine these two and calculate the sum. So 101 plus 82 is 183. 97 plus 80 is 177. Then the next two terms, 93 plus 78 is 171. The sum of the next two terms will be 165 and you would have identified what is happening here. Okay, 183, 177, 171. Now, if I'm considering two terms, two consecutive terms and adding them, so the new series that is written in front of you is also a decreasing AP with a common difference of -6. Okay. Now, what you have to do is you just have to look at the last positive term of this new series, consider that as the last term and calculate the sum and that will be the maximum sum. Okay, so I will stop at that time when the term will be minimum. When the term will be minimum, that means the last positive term of the series, after which the sum will keep on decreasing. Okay, so simplify this. Now, every term in this is of the form 6k plus 3. So I can say that the last term of this series will be 3. The number of terms will be 183 minus 3, that is 180, divided by 6 plus 1, which will come out to be 31. So there will be 31 terms in this series. So the sum of this series will be equal to n by 2 bracket a plus l. Okay, simplify this. 31 multiplied by 186 divided by 2, that is 93. Calculating the sum, 3, 9 and 9, 18, 1, 27, 28. So 2883 should be the final answer, should be the maximum possible sum of this series. And yes, that is the correct answer. So that was question number 12. I've tried to make it easy. I don't know if you'll find it easy or not, but this is an alternate way of solving this question. Let's move on to the next question.